Hi, and welcome back. Now let's get started with loading and preparing our image data before we actually start training our deep learning networks. Alright, so let's go ahead and open this file, 15, creating a CNN using TensorFlow 2.0. And here we go. So it's loaded now. Alright, so now let's get started. So what I've done, I've created this notebook where I've put a lot of different steps in between, and a lot of these steps have important notes in between so that it can help you guide you through this project on your own. So the project we're about to do is creating a model based on the MNIST handwritten digits dataset. So first step in this whole process is loading our data. Now loading our data is probably a minor part of it. However, if you're loading actual image data from a raw dataset, it can be a bit tricky sometimes. So firstly, what we do is that we import our TensorFlow.keras datasets module that's listed right here, and then we import the MNIST dataset. And then we use the MNIST dataset, which is not a dataset just yet, but it's an object that contains the data, to load our data right here. So we apply this function load data, which is part of this object that we're importing here. And then that basically gives us our data right here. It returns a tuple of data. You can read about how the data is described here, or you can click here and actually get more information about the sample datasets that Keras provides. And what we can do, we can actually look at the shape of each dataset here, because what we get is 4 different datasets. We get X-train, Y-train, X-test, and Y-test. Now, what are these things? X-train is the bulk of our data. It is just our raw data that we're going to use to train our model on. Y-train corresponds to the same number of entries as X-train. However, it's the labels for X-train. And X-test and Y-test are similar. It's the test data set that we use to test the model that we create using this data, X-train and Y-train. So by printing the shape of X-train here, we can see we have 60,000 rows or 60,000 entries or individual sets or pieces of data. And 28 and 28 here are the dimensions of our data. Remember, this is an image data set, which you'll see shortly, and this data contains 60,000 entries here. And what this does is loads our dataset. It may take a couple minutes maximum, depends on your internet speed if it has to download the dataset. But mine is already downloaded, so you can see it just took about 5 seconds to load our dataset here, and we are printing the shape here as well. So now this is step 1, loading the raw dataset. Step 2. Now you don't always have to do step 2, but it's a good practice. It's examining and taking a look at the different dimensions and shapes and number of entries of the data. So we can see, I'll just run this here, shouldn't take too long. And now you can see the shape of the data, which we printed out before. So we have some little words here that go before, so it helps explain to you what you're looking at. So we have 60,000 entries for X-train at 60,000 images that are 28 by 28 pixels that are all grayscale, by the way. If it wasn't grayscale, you'd have a 2-dimension 28, comma 3 being the RGB colors in it. This one you can see, as I said, 60,000 samples of our training data. Number of labels should be the same, 60,000. Again, in our test data, 10,000 and 10,000 samples. Remember I said you always want to have more bulk of your data in the training data set. Usually a 70-30 ratio is good. However, you can do 80-20, even 90-10 sometimes, depending on the quantities of data. I'm showing you the dimensions here as well of X-train, how much labels, and similarly for X-test. So now let's do something a bit more fun. Let's take a look at some of the random images in our dataset. So this is some OpenCV code here. What we're going to do, we're just going to run through 6 images here using a for loop right here. From 0 to 6, we are going to generate a random number between 0 and the number length of X-train. So this is going to generate a number between 0 and 60,000. Okay. And then we're going to just get that X-train sample right here by using this as the index. We get our image, we resize our image just to make it bigger because 28 by 28 is going to look tiny on my laptop screen. And then we're going to show the image here. So let's just run this code. And you can see it looks like a 0. All right. Let's see another one, 6. Remember, these are handwritten digits, so they're all going to be different to each other, like different types of 0s, 6s, 7s, 9s, 3s, 7s, and so on. Now let's do the same thing. Now I haven't introduced this to you before, but you can also use matplotlib to show images as well, okay? How you do it, use the plt imshow function. This is what you're going to show here. This is going to be an XY type dimensions here, 28 by 28 grid. and you're going to use CMap, so color map, and you're going to just use gray because this is a grayscale image. And this is a subplots here. What this means is that we're going to have tree by tree. And the last digit 1 simply means that we're just talking about the first plot here. That's why it says 2, 3, 4 and increments there. That's because you're talking about different plots when you're referring to this here. So this just refers to the first plot, second plot, blah, blah, blah. So now let's show our plots. Now the code is already run, but let's just run this here. Oh, just so you know, a lot of times, the first time you run a matplotlib plot, you're going to need to do it a second time, just because the first time it actually doesn't show the image. So there we go. So now we have 1, 4, 2, 5, 2, 7. Very neat way of putting images, displaying images without using OpenCV. And because it's a matplotlib plot, you actually get the axis scale here, which is 28 by 28, as you can see. So now let's move on to step 3. Step 3 is preparing our dataset for training. So let me run through this code and I'll talk about this, go through it. So firstly, let's just get a number of rows and image columns. As you can see, it was 28 by 28, and you know what we're doing here, we're just taking the first image from XTrain and getting the shape. This is the rows and this is the columns here. Quite simple, which we've done a few times before. Now, let's get our data, not date. Let's change this. Whoops. In the right shape needed for Keras. Now, what I should have started this chapter off with telling you is that we're using Keras within TensorFlow 2.0, which is why if you go back to our top, our imports are from this module here. It's TensorFlow.keras.datasets. Previously, when we used to use Keras before TensorFlow 2.0, you would have to import TensorFlow separately as well. Actually, you didn't have to import TensorFlow separately unless you were using a TensorFlow operation. You just have to remove the .tensorflow part and you could directly import from Keras. But we no longer need to do that in TensorFlow 2.0. Just something to note. Hope I didn't distract you too much from your learning with that, but now let's move back to this. So now, as I said here, we need to add a 4-dimension, thereby changing our original image shape from this to this. So what we simply need to do is we use a numpy.shape function, because these are all numpy arrays, all of the data we get from Keras. NumPy is a very fast, efficient numerical computation module within Python. It's built off Cython, so it's super fast. And what we do, we just put the shape here. So we have, this is a 28 by 28 here. This is the 60,000 rows we have here. And this is just the 4-dimension we want to add, which is just 1 dimension here, just because we just need to get it in this format for Keras, okay? And then we just store the shape here. This is going to come in useful later on. And what we do as well, we change our type to float32, because Keras needs float32 type digits to do the numerical computations involved in deep learning training. So we just change it, just change this NumPy array as type float32. Don't remember what it was before this, but it most likely was unsigned int8, which is uint8. Okay, I believe it's that. If it is not that, I'll correct it and put a note at the end of the video. Okay, originally. So now also, we do need to normalize our data. Now, normalizing is not always necessary, but it helps a lot with the deep learning computations. And what we do, we're changing the range of the data from 0 to 255 to now limiting the scope from 0 to 1. So that's simply done by just dividing by 255, and we just put 255.0 to keep our float type. Now, this isn't necessary most times, because we did this operation before. If we didn't do this operation above here, and we simply divided by 255, it would give incorrect values, because it would just be 0 or 1, because it wouldn't actually be give it the decimal form here. So just something to note with Python. When you're messing with different data types, be careful. If you want to keep something as a float data type, always put it as a decimal form, okay? And then what we do, we just print out the shapes here and end. So you can see that we didn't actually change anything, and the shape we wanted is now what we were getting. So let's just run this quickly. And yeah, so this is the shape we wanted. Our NumPy array for XTrain is now in this format, and yes, our samples are the same, so it's good. And remember, we did this for only XTrain and XTest. We didn't need to do this for YTrain, our labels, and YTest, because what we're doing with our Y labels here is that we're going to do something called one-hot encoding our labels. This is an image I've created here that shows you what one-hot encoding is. So you know how we have 0 to 9 labels or classes? what we want to do, instead of having it in one column, we're going to put it into 10 different columns here. And this columns are going to be, the first column is going to be representing 0, second column 1, and so on. So anytime something's like a 4, instead of having it as a 4 here, we're going to have it as a 1 here, and all the rest zeros. Likewise for 5, likewise for 2, and blah, 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 and 6. And the reason we do this is firstly, well, because Keras requires us to put our label data set in this form. And secondly, it's because there's no real ordinal relationship, so we kind of want to keep them independent. Otherwise, you can get some bad performance or unexpected performance if you were to keep your labels like this. Now, I don't believe in Keras you can do it any other way with your labels. Maybe you can, I just haven't had that much experience with using it to see if we could, okay? Anyhow, just assume for now you always do have to do this, and you can do this by using toCategorical here, which is a built-in function in Keras. So that's pretty cool. Also, pandas, if for those of you who are familiar with pandas, pandas has something called getDummies, which does something similar as well. So now let's move on to creating our model, which is the next part of our video. So just to quickly summarize what we've just learned, you've learned how to load data from Keras's default data sets. You've learned how to reformat this data or reshape this data in the format required by Keras for XTrain, and also for the label data where we use one-hot encoding. So now let's move on to training our CNN and analyzing its performance in our next video. Thank you.